everyone. Welcome back. It's Miss Wagers, and we are going to continue reading the anatomy of a volcanic eruption. We are on lesson 3 today. Our learning intentions. We are learning to find and use key details so we can explain our understanding of the text. So really, this is one of those lessons where we're really focusing on using text evidence. We know we're successful when we can identify the keywords and details in the text, and also to use those keywords and details to explain the text. So let's go ahead and get started. We have some foundational skills, of course. Today you are focusing on Greek and Latin prefixes trans and tele. Now I want you to remember that trans means across, beyond, or to another place. And tele means over a long distance. So you can always think about that word telephone. You can speak to someone over a long distance. So I can call up my mama, but she doesn't have to be right next to me. She could be hundreds or thousands of miles away, and I could still be able to talk to her. So your fluency read that you have today is a mission for Mother's Day. And the words with the Greek and Latin prefixes trans and tele that you have are telephone, like I just mentioned, television, transformed, translate, transmit, transportation, and transported. So make sure you take your time and really focus on those words with those prefixes trans and tele, so that way you can do your best on that reading today. For vocabulary, we have the word originate. So from the text, it says crater, an indent in the top of a volcano where the lava flows originate. And let's look at our picture here. This is kind of an interesting picture. On that little post, it says, here, 1,475 feet above the ocean, the mighty Mississippi begins to flow on its winding way 2,552 miles to the Gulf of Mexico. So this post, which appears to be an old tree, that is where the Mississippi River originates. What would be another word for originate be? Right? Another word for originate, you might say start, or our definition today is to begin to exist. So the Mississippi begins a long way from the Gulf of Mexico, and it travels all the way across the United States until it finally dumps into the Gulf of Mexico. So let's look at chapter 2. And we have some cool diagrams in here. We can see this diagram of what a volcano, like what the parts of a volcano actually are. So let's start with the top, the vent it's called. It says the top opening of the conduit. Okay, I wonder what a conduit is. I bet we'll find out. The next one, the flank, is the side of a volcano. So the side of a volcano is called the flank. Then we, of course, have lava coming out of it. And it says crater. So the crater is right up here. Got to look at where the arrow is pointing. Crater is an indent in the top of a volcano where the lava flows originate. So remember, originate is to begin to exist, or even just to start. We have the ash cloud here. And then it also tells us the summit is the highest part of a volcano. So the very top of the volcano is called the summit. We also could have a summit of a mountain, which is the top of the mountain. The conduit, that's what I was wondering about. What is a conduit? It says the conduit is a pipe that the magma travels up to reach Earth's surface. So the magma is going up the center of the volcano until it reaches the surface. And then lastly, at the bottom, we have the magma chamber, the bottom part of the volcano where the magma is stored. So the magma chamber is at the bottom, and then it goes up the conduit and out the vent. Then it could even roll down the flank, I suppose, right? And so then we also have this little red box on the right that says volcano classification. So it says active volcanoes. Volcanoes that have had at least one eruption recorded in history. If it just erupted one time in history, then we say it's active. Dormant volcanoes. Volcanoes that have not erupted in historic time, but are expected to erupt again in the future. So a dormant volcano would be one that we don't know when the last time it's erupted, but we expect that it will happen again. And then we have extinct volcanoes. Volcanoes that have not had any eruptions in the last 10,000 years and are not expected to erupt again. So we have 3 different volcano classifications: active, dormant, and extinct. Just like the dinosaurs, right? So we do have a stop and think question that we're going to answer with this. So where can you find information about how scientists classify volcanoes? Did you say the red box, Miss Wagers? Duh. Right? It's exactly where we just talked about. In this red box on page 15, we can find information about how scientists classify volcanoes. And what are those 3 classifications? We're using details from the text, friends. All right, what's the first one? The second one? And the third one. Right, so we have active, dormant, and extinct. Again, we are looking right here in this red box. I'm not having to make anything up off the top of my head. I can look right in the text to find those answers. Then lastly, what detail is discussed in each of the classifications? So this one we have to think a little bit harder. What detail is discussed in each of these classifications? So let's see, volcanoes that have had at least 1 eruption in recorded history, that's an active volcano. Dormant volcanoes have not erupted in historic time, but are expected to erupt again in the future. And extinct, remember, are volcanoes that have not had any eruptions in the last 10,000 years and are not expected to erupt again. Did you guys notice there was a key word that I kept saying over and over again? What was it? Goes boom, eruption, right? Eruption is the word that we said over and over and over again. That detail, it's talking about how often or when the last time the volcano has erupted. That's the detail that's in each classification, is when the last time the volcano erupted. There we go. And we're also going to talk about types of volcanoes today. So it says that there's different kinds of volcanoes. These include stratovolcanoes, cinder cones, and shield volcanoes. So let's learn more about these. So it says stratovolcanoes often take millions of years to form. Numerous eruptions and layers of ash and lava have built up on their sides. They are sometimes called composite volcanoes. Examples include Mount St. Helens, Mount Fuji, Mount Rainier, and Mount Hood. So we have stratovolcanoes. They take millions of years to form. Let's look at cinder cones. It says cinder cones are the simplest and smallest volcanoes. They are relatively short, usually 1,000 feet or 305 meters or less in height. Many have bowl-shaped craters at their summit. Most originate from single eruptions. So just one eruption. How's that cinder cone? Then let's talk about lava domes real quick. So it says lava domes form when the lava that pushes out of a conduit is too thick and sticky to move a great distance. It builds up into a round, domed mass of lava. An example of this is the Novarupta Dome in Alaska. Mount St. Helens built several lava domes in its crater after violently erupted in May of 1980. So a lava dome happens when that magma is so thick it can't really even get out of the conduit. It just kind of bubbles up and gets stuck on the top. And then lastly, shield volcanoes. And we can see this picture of the shield volcano on the right-hand side. It says shield volcanoes are built up almost entirely of lava flows. They are called shield volcanoes because their shape resembles a warrior's shield. These volcanoes are generally very large and wide. Mauna Loa and Kilauea in Hawaii are examples of shield volcanoes. Awesome. So they have an example of a shield volcano here. And then remember, this is a stratovolcano. So you can look and see how they look similar and how they also might look a little different. Other volcanic structures. There are other types of volcanic structures besides mountains. These include plugs, mud volcanoes, geysers, fumaroles, and hot springs. So let's talk more about geysers. It says geysers are hot springs that periodically erupt, shooting steam and water into the air. The water is heated by the hot rocks deep in Earth's crust. So here they're showing us a geyser in New Zealand. We also have some geysers in the United States. One is called Old Faithful, and you can usually watch it online. They have a live stream. Fumaroles. Fumaroles are openings in the Earth's crust near a volcano. They are spots where hot steam and other gases escape. Yellow sulfur deposits often encrust the outside of a fumarole. Fumaroles are common on active volcanoes. Increased fumarolic activity on dormant volcanoes is a clue that a dramatic eruption may occur in the future. And so it says scientists collect samples at a fumarole. And then lastly, we have plug volcanoes. Now, this is interesting. This doesn't even look like a volcano. It looks like a big flat mountain, right? So plug volcanoes are landforms that occur when magma hardens inside the vents of active volcanoes. The magma plugs the vents. Over time, the outside part of the volcano is worn away through erosion. Eventually, the plug is all that is left. An example of this landform is Devil's Tower in Wyoming. And it also tells us that local Native Americans consider Devil's Tower to be a sacred place. So imagine this is actually just like the inside of the volcano, the conduit where it all got plugged up, and the rest of the volcano has actually eroded away. And we do have this fact from geysers that I didn't read yet. It says geysers can be found on every continent except Antarctica. So they can be found everywhere. And like I said, including in North America, in the United States even. So our focus today, remember, is on keywords and details. Good readers reread keywords and sentences in the text to better understand the author's particular choices and how these choices shape their meanings. So the author chooses specific words when they are writing about a topic, right? So our author today, they didn't just say that volcanoes are big hills. They used specific words and they told us what they were made out of. So we're going to look back in the text to look at some of these key details. So let's look back at cinder cones, for example. I want you to first notice the length of the sentences in this section. So it says cinder cones are the simplest and smallest volcanoes. They are relatively short, usually 1,000 feet or less in height. Many have a bowl-shaped crater at their summit. Most originate from single eruptions. So I want you to notice here that these sentences are actually pretty short. They're about 10 words or less, and that's pretty short for a sentence, y'all. So they've kept them very simple. And the reason the author may have done that is because they're sharing with us new information. You probably haven't heard of the cinder cones before. I know I hadn't before I read this story. And so when authors give us shorter sentences, it's easier for the reader to comprehend and understand what they're saying. And let's look at fumaroles, and we're going to look at the sentence lengths here. So fumaroles are the openings in the Earth's crust near a volcano. They are spots where hot steam and other gases escape. Yellow sulfur deposits often encrust the outside of a fumarole. Fumaroles are common on active volcanoes. Increased fumarolic activity on a dormant volcano is a clue that a dramatic eruption may occur in the future. So notice on this one, most of the sentences are very short still, just like on cinder cones. However, the last sentence is longer and it gives us more information about fumaroles. So it tells us in that very last sentence that increased fumarolic activity on dormant volcanoes is a clue that a dramatic eruption may occur in the future. So now they're giving us more information instead of just like if there's more activity, then there's a higher chance that there's going to be a new eruption. So there's kind of two parts of information that have to go together there, where the rest they just said fumaroles are openings in the Earth's crust. There are spots where hot steam escapes, and they're giving us these short little pieces of information to help us understand what a fumarole is. And then at the end, they tell us how we can use fumaroles to predict more eruptions. So let's now look a little bit more about some key words that they use to describe stratovolcanoes. So we're just going to look in the black box. Stratovolcanoes often take millions of years to form. Numerous eruptions and layers of ash and lava have built up on their sides. They are sometimes called composite volcanoes. Examples include Mount St. Helens, Mount Fuji, Mount Rainier, and Mount Hood. So I want you to stop and think. Do you think the examples of these stratovolcanoes are keywords? Right. Those we probably wouldn't consider a keyword to describe stratovolcanoes. They're giving us examples of them, but if I don't know what Mount Rainier is or what Mount Hood is or any of those examples are, that's not going to help me to understand stratovolcanoes. So I wouldn't say that those are keywords that help to describe them. What I would say helps to describe some keywords is that they take millions of years to form. Okay, and then it says numerous eruptions. So numerous means more than one, and it says layers of ash and lava built their sides. Those are all key words that can help me understand what a stratovolcano is. They're simple, they're easy to understand, and they give me a good, clear picture of what a stratovolcano is. I know they take a long time to form. They erupt a lot. They have layers of ash and lava on their sides that built them up. And then also you could even include that they are sometimes called composite volcanoes. But again, if you don't know what that word composite is, that's not necessarily going to help you understand what a stratovolcano is. Let's try this again with cinder cones. We're going to look for keywords to describe cinder cones. Cinder cones are the simplest and smallest volcanoes. They are relatively short, usually 1,000 feet or less in height. Many have a bowl-shaped crater at their summit. Most originate from single eruptions. So what words do you think are important there? Which ones do you think are key to describing cinder cones? There's two in particular that really stood out to me. And those are that they're the simplest and the smallest volcanoes. I think that's important for me to understand and remember is that cinder cones are simple and they're the smallest. So when I'm comparing them to the other types, I know, oh yeah, here's the simplest, they're the smallest. Because then it goes on to tell me that they're short. Well, that makes sense with them being the smallest. And then you could also think about them having that crater at their summit. And remember, the summit means at the top of the volcano. So they have a crater at their summit, they're simple, and they're small. So right there, I am describing cinder cones with less words and details than the author used because I'm only thinking about those key words and details, the ones that are really important. They're simple, they're small, and they have a crater at the summit. All right, we're going to try it again with lava domes. So let's think. Lava domes form when lava pushes out of a conduit. That pushes out of a conduit is too thick and sticky to move a great distance. It builds up into a round, domed mass of lava. An example of this is the Novarupta Dome in Alaska. Mount St. Helens built several lava domes in its crater after it violently erupted in May of 1980. So again, in those last two sentences, it's telling me about actual lava domes, but those aren't helping to really describe what a lava dome is to me unless I know what those examples are. So when I'm thinking about these key words, I'm thinking about lava. It's too thick and sticky to move. I know what thick and sticky is. Think of like glue, right? It gets real thick. And it's not moving anywhere. It's not rolling. It can't slide down the side of the volcano. So I'm thinking thick, sticky lava that makes a dome. Those are some key words that are really important to help me understand what a lava dome is. So we have thick, sticky lava that makes a dome at the opening of a volcano. And lastly, let's think about some keywords for shield volcanoes. So the shield volcanoes are built up almost entirely of lava flows. They are called shield volcanoes because their shape resembles a warrior's shield. These volcanoes are generally very large and wide. Mauna Loa and Kilauea are examples of shield volcanoes. So again, let's think. It says their shape resembles a warrior's shield. They're very large and wide. So I'm thinking shield volcanoes are large and wide and they resemble a warrior's shield. Those are key words that are helping me to understand what a shield volcano actually is and looks like. So we are back to our learning intentions for today. So we are learning to use and find and use key details so we can explain our understanding of the text. We know we are successful when we can identify those keywords and details in the text. So that's really what we are focusing on today is Let's identify, let's find those words that are the most important to help me understand. Check mark. And then use the keywords and details to explain the text. And we did that as well when we're thinking about what are the different parts of the earthquakes, or what are the different types. Earthquakes, I said earthquakes, that's our last unit. Now we're on to volcanoes. What are the different types of volcanoes, and what are the different parts of volcanoes as well? So we can use that to explain volcanoes a little bit better. All right, check mark. Your reading response for today: which type of volcano do you think is the most interesting? So you get to talk about your opinion, but you have to use key details to explain why that type of volcano interests you the most. Okay? So which one do you think is the most interesting? Just make sure that you're using those key details, text evidence, to help support your answer. That is all for today. I hope you have a wonderful day. Be kind to one another. Do all of your work, and I will see you guys later. Bye.